Welcome back to another episode of Christian Natural Health. Today, I'm very thrilled to have Dave Stetzer with us. Dave has been an electrician by training, education, and experience for over 30 years. He joined the United States Air Force, attended electronics school at Keesler Air Force Base, at the time the world's #1 electronics school, and was given top secret military clearance, as much of the electronic equipment he worked on was and still remains highly classified. In 1975, Dave founded Stetzer Electric Incorporated, specializing in power control in industry, municipalities, and motor control centers, focusing his attention on power quality analysis and troubleshooting. This led to the founding of Stetzer Consulting LLC and the development of the Stetzerizer or Graham Stetzer filter and microsurge meter in conjunction with the late Professor Martin Graham. Dave has been an Institute of Electrical and Electronics Engineers, IEEE, member since 2000. For his extensive and exemplary work and research, Dave was nominated for and now holds the IEEE senior member status. Welcome, Dave. Thanks so much for joining us.
No, thanks for having me.
Yeah. Okay. So I'd love for you to define the difference for our audience between dirty electricity and other types of EMF. Is it kind of qualitatively different, or is it kind of more the same? What's the difference?
Well, normally when we talk about EMF, we're talking about electric fields and magnetic fields. That's like a force that kind of travels through space.
Mhm.
Dirty electricity, um, it's high frequency transients that are on your power line. If you remember in the old days, you don't remember because you're too young, but uh, when we bought the computers, when we had computers and stuff when first came out, you always had your computer technician over there because he said, well, it was a spike that comes on the
Uh,
line.
okay.
Basically what it is a transient. It's
Okay.
a like a extra voltage spike that comes in and it takes out your chips. Well, then the computer, it happens so much that the Sabima Computer Business and Manufacturers Association, they said, well, let's redesign a chip. So now they got what they call a Sabima curve, and you have to be able, your chips have to take a certain amount of voltage for a certain amount of time.
Uh-huh.
But like Martin Graham, who used to say, well, we can't redesign a person, we can redesign a chip.
Yeah.
So, but it affects people.
Uh-huh.
And what happens is the dirty electricity, if you go back to your seventh grade science,
Mhm.
remember the periodic table, you had the atom with the electrons, neutrons, okay. Okay, so you got these electrons. They're negatively charged particles. So
Mhm.
if there's a positive transient going in the positive direction that's on the building's wires,
Mhm.
and the electrons in your body are kind of attracted to it, so they start moving toward that. They don't leave your body, it's not going through space, but
Sure.
they get attracted, they start moving. Well, then of course it goes negative, well then they move back and forth. So you actually, it's called capacitive coupling, that's how it works.
Okay.
And you actually get this current flow in your body.
Interesting. So I was under the impression, I guess, what I thought of as dirty electricity sounds like it must only be a part. I thought that it was when the electricity that's coming into the house, there's a bottleneck when it needs to be stepped up or stepped down for a particular device. So it sounds like that creates a bottleneck, and maybe that's a piece of it, but really it's more the surge when you have a spike here and there. Is that true? Or did I
Well,
understand
there's
you?
multiple spikes on the line. I mean, it's
Okay.
dirty, okay, but you're kind of right. You just
Okay.
need a little clarification here.
Okay.
Okay, so it comes in and we have 120 volts or 240 coming into our house.
Okay.
So we have a computer that's running on DC current, okay? So we
Okay.
have to take that 120 volts and turn it into 9 volts, 12 volts, or whatever our devices are, 5 volts,
Okay.
DC. So
Uh-huh.
what we do is the current has this big sine wave, right?
Mhm.
And so
I
we
see
use
alternating. Yeah.
just portions of it. We're turning it on and off, and
Sure.
we create, it's called a switch mode power supply. In order to change the AC to DC, we have this problem. And
Uh-huh.
things like, well, like a Dell computer, for example, a tower, that'll put 16.5 kilohertz back on the wires.
Mm.
Apple computers put 12.5 kilohertz back on the wires.
Mm.
Uh, you know, the smart meters, which is really bad, the transmitted signal now
Mhm.
has to be transmitted, so we have to have a DC circuit for it. So that'll put 50 kilohertz back on the wires.
Okay. Okay. So, all right. And then, so once it's back on the wires, then it does what to our physiology? Why is this a problem for us?
Well, then it propagates over long distances. It's
Okay.
there. It's dirty power. Somebody coined the phrase.
Okay.
We wrote a paper on it. Martin Graham did,
Mhm.
on called a ubiquitous pollutant. But from UC Berkeley. But what it is high frequency transit. It affects the body or people's body, and it's on all the wires. Compact fluorescent lights, for example, light dimmer switches, things like that. But in in a in a city, for example,
Mhm.
we'll have like maybe one transformer for 8 or 10 houses.
Mhm.
So you can be in one house and you can go over to another house and vary the dimmer switch and you can see the levels change in your house. So you see
Oh,
it's
wow.
all tied together. The grid is interconnected. And
Uh-huh.
so you can say, well, I don't have a smart meter, but yeah, but if your neighbors do, you're still getting affected.
Interesting.
Or if you got a computer or a light dimmer switch and your neighbors don't, you're still affecting them.
Okay, okay. And so when you talk about affecting, what does this mean from a physiological standpoint? Like what kinds of symptoms do we see? What's happening to the physiology that leads to the symptoms?
Well, I'm not a medical doctor, okay, but I went to Russia and I spent a lot of time with some of them
Mhm.
and professors of medicine because they have the same issue,
Yeah,
okay? And the
right.
Russians made weapons with this stuff, okay?
Uh-huh.
And so you've heard of like uh, that Havana syndrome, or the ringing in your ears, things like
Yeah.
that. Well, usually you can find 50 kilohertz when you get the tinnitus or tinnitus.
Hmm.
And I've always fallen to 50 kilohertz on the line.
Hmm.
And so, but the United States Navy did a lot of research, and so did the Air Force as well. And most of that stuff was classified, but they have declassified it now. So they've got, uh, like the symptoms are quite lengthy, but it affects different people in different ways. And again, a lot of it's frequency specific.
Hmm.
Okay.
Okay.
But you get headache, dizziness, nausea, difficulty breathing, insomnia, fatigue, muscle spasms,
Hmm.
pressure in or behind the eyes, heart palpitations, they got it like respiratory things like that. And in fact, if you look at um, chronic fatigue syndrome,
Hmm.
which there's no known cause or cure,
Right.
fibromyalgia, no known cause or cure,
Hmm.
ADD, ADHD, no known cause or cure,
Hmm.
they're the exact same symptoms as
Hmm.
radio wave sickness. So
Interesting.
they overlay, which radio wave sickness, there's a known cause and a known cure.
Right, right.
So it's exposure to higher frequencies.
Sure.
So if we went in and we remove those higher frequencies
Uh-huh.
and people get better, then
Clearly there's a
obviously
correlation.
that's the cause. If you
Sure.
want to show that A causes B in
Yeah,
science, you remove A, B goes away.
that's way. Right, sure.
There you
Yeah.
go.
So, okay, so then the fact that as you were describing that the flow of electrons, they're attracted to something that's positively charged, our body runs on currents. So
Mhm.
does this largely happen as a result of disruption of ions, like they're in the wrong place or they're flowing in the wrong way or something along those lines?
Well, there's been a lot of research on that,
Yeah.
but you got to remember your body runs on current. You're absolutely right. But it's DC current, direct current, where the
Mhm.
electrons go from a negative charge to a positive charge. Okay. So if you got uh, a cancer cell starting to grow in your ovary, okay, there's a signal that goes from your ovary up to your brain, says, hey, there's something here that doesn't belong.
Uh-huh.
Okay, so the brain says, well, let me check it out. So it sends a signal back and it says, okay, yeah, that's right. I'll send something down there to kill it.
Mhm.
Okay, so that's always the electrons are moving in one direction. Okay, DC current.
Mhm.
Now the dirty electricity or EMFs, things like that, is AC current, alternating. So like charges repel, unlike charges attract. So
Uh-huh.
okay, so now we introduce the AC, we interrupt those signals. Okay.
Okay. Yeah.
The other thing that we noticed, okay, and Dr. Sam Milham, who's done some world famous epidemiologist,
Mhm.
he did some research at the Olympia Washington Library.
Mhm.
And he took 12 people and he checked the neurotransmitters in
Mhm.
their urine. Now, you
Right.
don't want to have any neurotransmitters in your urine. That information we're talking about that's being transmitted,
Mhm.
it's transmitted on neurotransmitters. It's like the electrical grid of your immune system.
Mhm.
So now nobody had less than 300 neurotransmitters coming out
Mhm.
in the urine for 12 weeks.
Mhm.
Cleaned up the electrical environment,
Mhm.
and they checked people for the next 12 weeks. Okay, but within 8 hours, nobody had more than 3 neurotransmitters in their urine.
Mhm.
So it could be, is it affecting, the neurotransmitters, or the signals aren't getting there? I mean, we've had people with autoimmune diseases, and then as soon as you clean up their electrical environment, their immune system goes back to work.
Yeah. And I thought it was really interesting and when he mentioned that he specifically was saying that it was the norepinephrine and the epinephrine that were on the low side, which implies that you're depleting your catecholamines because you're super stressed out by the fact that your body is exposed to all of this. Find that very interesting as well. So what might somebody look at in their environment in order to say, how likely is it that this is a problem for me? I mean, what kind of just visually, I know sometimes you just have to measure, but are there any things you can specifically say that's going to be a dirty environment?
Well, modern day electronic devices, okay?
Yeah.
In 1972, we had an oil embargo, so we had to get more energy efficient. So we
Mhm.
started using current in a different manner. We started chopping it up. We used
Yeah.
variable speed frequency drives. We went energy efficient lighting,
Mm.
things like
That why?
that.
Interesting. Okay.
So we had to
Oh.
go, yeah. And so in chopping this up, this sine wave, we
Uh,
created the dirty electricity or higher frequencies,
oh,
okay?
wow.
So
Okay.
now we have energy efficient lighting. So if you walk into a building and you're looking, that's a good question, okay? But
Sure.
where I really, even myself, I'm affected by it. But if I have to go to like schools or office buildings, like a computer lab is the worst place for me, in it,
Yeah.
because you're surrounded by all these electronic equipment. People
Sure.
who work in like offices, like I feel sorry for the girls at school, or well, they try to make things as efficient as they can for them. So people come in to pay the lunch money. They got a computer in front of them. They got copy machines behind them. They got all this electronic equipment in this
Mhm.
little, and so then they wonder why they have migraines and they're really sick and things like that.
Sure.
So, but if you've got a modern day electronic equipment, I mean, there's hardly anybody that doesn't have it, and
Uh-huh.
nobody is putting in non-energy efficient lighting and things like that. Like
Right.
LEDs, they're
Mhm.
terrible. Okay, they put 62.5 kilohertz back on every wire in the building.
Mhm.
Uh,
Mhm.
the,
So one question I have is about traditional quote unquote EMF. So the electric fields and the magnetic fields decrease exponentially as you get away from the source, correct? Like as far
that's
as how it's going to affect your body.
yes.
So, but dirty electricity is different because it runs on the wires. Is that true?
The dirty electricity is on the wire, but
Uh,
it's higher frequency.
Okay.
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 So when we're looking at, uh, for example, if you got something that's drawing 2 amps, you might get 4 milligauss if you're just put your Gauss meter right next to it. Okay.
Right.
But if
Uh-huh.
you move 4 inches away, it drops to zero. But
Right.
you're looking at the 60 cycle field. So that's like you have a Gauss meter, you're looking at the 60 hertz
Okay.
part, like power line frequency, things like that.
Right.
But it's sort of like I use an example, okay, an analogy of going to Mexico and drinking the water. And you get sick in Mexico, right?
Right.
So then you say, well, gee, water makes you sick. But the
Uh,
guy in New York says, I'm drinking, 10 glasses a day and I don't get sick.
right.
So who's lying here? Neither
Sure.
one.
Right.
So that's what Graham and I did is we said, okay, how can this be? So we use an oscilloscope. We always use scopes.
Mhm.
And we can actually, it's like a microscope, okay? So we're saying, hey, wait a minute. This isn't good, clean electricity. There's
Mhm.
something on it, these higher frequencies,
Mhm.
okay? And energy is proportionate to frequency. That's
Mhm.
Planck's law, it's same as
Right.
Ohm's law and all that, right?
Yeah.
So now we have this high frequency energy that's on the wires, and
Uh,
that can go farther, okay?
okay. Okay.
That
Got
can
it.
farther. And there's more energy there, see? And so it's like, so like going back to the analogy, I mean, it's the bacteria. When we looked at the water in Mexico, it was the bacteria that made you sick. That's
Right.
why for every 10 studies you say, well, power line frequencies make you ill, you'll find 10 studies that says it's inconclusive.
Mhm.
Well, I was in Russia and there was a bunch of scientists there and they were arguing because teams did both good research. But then I said, did you save the waveforms? Yes. And so
Mhm.
then what they did is they said, okay, they went back and looked at the waveforms.
Mhm.
The ones that were crappy or high frequency waveforms, okay, that was conclusive that yes, it causes cancer and it causes all these problems.
Mhm.
The ones that were clean, the results were inconclusive. So it's like it wasn't really the water that made you sick.
Uh-huh.
It was the water was just a carrier. It was the bacteria that made you sick, and you can put it on a slice of bread and get sick.
Yeah. Okay. So it's the frequency and the spikes that are on that. So I mean, I'm picturing a sine wave, but then the sine wave has like little jiggles on it. That's the dirty electricity that you're describing, right? Kind of.
That's right. Yes.
Okay.
And
All
the
right.
more jiggles,
Yeah.
okay,
Okay.
then that's the higher the frequency.
Oh, I see what you mean. So I was thinking of the actual alternation of the original sine wave, but you
That
mean
happens
the
60
jiggle.
times per second. But
Got it.
on the 60 times,
Okay.
there's like you're
Those
calling them
those little
jiggles, that's
jiggles.
fine. Like
Okay.
little saw teeth. Yep. Those
Right.
are the spikes.
Got it. Okay. So when you're referring to you walk into an office and somebody has tons of electronics all around them, if like let's say they're further away from their power line, so they don't have they're not as close to the transformer, I suppose. It is the transformer, right? That silver box that
Yeah.
typically does. Okay. So if they're further away from that, and most of the things they have that are plugging into the wall, they're not smart devices, they're just regular plugs. Is that cleaner or not necessarily?
Not necessarily, because it isn't just what you have, it's
It's
what the
whatever
neighbors
else.
have,
I see.
whatever. Yeah.
Okay,
So then we got to measure it. Yeah.
got it.
But
Okay, so at that point, that makes the
yeah,
difference.
but there's no place that's going to be clean
Yeah, these days, unfortunately, that seems to be the case.
because you're affected by your neighbors. The whole grid is
Sure.
dirty.
Right,
Okay.
right. So, okay, so then when someone is using your microsurge meter, if
Mhm.
you were to plug that in and they were to see, so like let's say you mentioned that the smart meters are dreadful as far as putting dirty electricity on the grid. So if somebody has a smart meter, but they're not measuring particularly high dirty electricity, or does that ever happen? Or is it
I've
all,
never seen it.
oh, really? Okay. So what constitutes high dirty electricity, as far as the microsurge meter is concerned?
Okay. The microsurge meter we made because we use an oscilloscope, but they're $5,000 and nobody's going to go buy a
Right.
$5,000 scope. So
Sure.
what we did is we wanted to make a poor man's oscilloscope.
Uh-huh, uh-huh.
Okay. So that anybody could afford to, well, actually, okay. So, but an oscilloscope, it takes a lot of training and, okay. So let's make it as simple as we can.
Right.
And let's have a digital printout. Now, if you made the human body into an electrical model, you can look it up, it's Underwriters Laboratories model of the human body. The body will look like three resistors and
Mhm,
two capacitors.
mhm,
So a capacitor is a short to high frequency.
mhm.
So
Wait,
any energy.
pause for just a second. Can you define those terms for us?
Okay, a capacitor, it's an electrical component, okay? But it's
Okay.
a short for high frequency. In other words, high frequency will shoot across the capacitor,
All
okay?
right. Yep.
It's
Okay.
like a magnet to it, okay?
Right.
So what happens is if you get above 2 kilohertz,
Mhm.
okay, the
Yeah.
capacitors kick in. You don't have skin anymore, sort of like, on an electrical model, okay? So
Okay.
all the energy above 2 kilohertz dissipates internal to the human body. So
Oh.
we want to be below 2 kilohertz.
Uh-huh.
So if you look at the microsurge meter,
Mhm.
it's a curve, but it's not always, but usually below 50 is below 2 kilohertz. Okay. So
Oh.
you want to be below 2 kilohertz, then that energy is not dissipating internal to the human body. So if it's
Okay.
not going internal, it's probably not hurting it. Okay.
Uh-huh. Okay.
So that's where we come with that. Now, the smart meter puts 50 kilohertz back on the wires.
Uh,
So that's going to be way above 2 kilohertz, and that meter is going to read, you know, in the hundreds.
got it. Okay. So, and you also, I don't know if it was just you or if it was you and Dr. Martin Graham who created the dirty electricity filters as well. So if somebody then plugs one of those in and their microsurge meter is reading under 50, even if they don't remove the smart meter or the smart TV or all the things, are they okay? Or do they still need to get rid of all those things?
No, no, just plug it in.
Just plug
Look,
it in. Okay.
in reality, okay,
Yeah.
remember I said like a Dell computer, like we'll put 16.5 kilohertz back on the wires?
Right.
Okay, Dell knows that is exactly what they're putting on. Okay, so they could make a tuned filter
Mm-hmm.
and put it right at the computer, right at the switchable power supply,
Mm-hmm.
and then that would short that out. The same way with Apple could put a 12.5 kilohertz tuned filter. Okay,
Okay.
and so it, it's like a radio station tuner. Okay, if you want to listen to 104.5 megahertz, you tune your radio to that, then only that signal comes through, and you get a country music station out of Dallas, Texas, for example. Okay,
Yeah.
so we can make a tune filter for any of those frequencies. See, and so
Okay.
you shouldn't have to buy our filters or anybody else's filters.
Okay.
The manufacturer of this stuff should put it there.
But they
Like
don't.
light bulb they don't, right? And we went to them. We didn't want to have a product to sell because we
Right.
thought it took away from our credibility as experts.
Sure.
And they said, get the heck out of here. Because it had add $5 to the cost of the computer. Well, at that time, computers were selling for like $3,000. So
Uh,
what the heck is $5 more?
right, right, right.
So, but yeah, if you want to stay below 50,
Uh-huh.
now, can you have modern day electronic devices and can you use them and use them safely? Absolutely. Yeah.
Mhm.
This is an engineering solution to an engineering problem.
I see.
I
Okay.
mean, if you're working in the auto industry and you want to build this really super motor or something and but then it's going to run hotter, right? Okay, well, then let's give it some cooling fins
Right,
so we have more surface area and we can dissipate the heat better. I mean, this is like, okay, we have these high frequencies generated from creating AC to DC.
right.
Okay, let's put a tune filter in and get rid of it.
Get rid of it. Okay. So extrapolating that idea of the smart meter that then puts dirty electricity on the wires. What about, so back to the brick chargers or anything that gets plugged into an inverter or anything like that. So if somebody were to, like, let's say, instead of plugging in their phone by their bedside at night, they're going to be really smart and they're going to plug in their charger in the other room. Is that still putting dirty electricity on all of their house wires? I mean, I know
Yes.
it is. Okay. So it's better in the sense that we're not exposed to the electric field and the magnetic field because it's no longer proximate to the head, but you still have that issue
Still
there.
have the high frequency, yes. You
Yeah.
can go into your bedroom and plug, our micro surge meter in there, for example, and you
Mhm.
can go and have somebody turn on a light dimmer switch and vary it. Now, that's on a total different circuit. That's a lighting circuit, and it can be down in your basement,
Mhm.
and you can be upstairs in your bedroom, and then when they vary that circuit, you'll see that number go up and down.
Got it. Okay. So, and then on that subject, as far as the dimmers, so the problem, as I understand it with those, is the bottleneck thing again. So as you're getting less, as you're trying to decrease the amount of electricity that's coming in, now you've got more that's dissipating. Am I getting that right? Is that how that works? Kind of?
Well, the dirty power that's coming in, you just created more by using a dimmer switch.
Okay. Okay.
Okay.
So would you create less if you have a dimmer and you don't want to get rid of it? Would you create less if you have it all the way on? Or is it just as bad as if you have it like halfway on or barely on?
No, you're correct, okay?
Okay.
The dimmer you make it,
Yeah.
the
The
more
worse.
chopping of the sine wave you're
That's what
doing.
I thought. Okay. Got it.
Now, if you're gonna have it, and you absolutely can't get rid of your dimmer switch, you turn it if you gotta have it on, turn it all the way up, okay? It's still gonna chop. Even Lutron, who makes the very best dimmer switches usually,
Right. Yeah.
they'll still chop 5%, okay? So you're
Mhm.
still chopping, but have it all the way up. I always tell people, why don't you just, change the light bulb?
Mhm.
Or, if you really want a mood, light a candle.
Right, exactly. Yep. No, that makes sense. Okay, so along the lines as far as lighting goes, so fluorescent lights are dreadful. If someone has fluorescent lights, but they don't turn them on, like let's say they work in an office building and they don't have control over that. If they just don't turn on the lights above them, is that good enough, or do they have to actually unscrew the bulb? Does it matter?
No, no, if it switches off, you're
You're
not
good.
chopping the sine wave.
Okay, so that's good. Okay, and so what about solar panels? How bad are they and why?
Solar panels are really bad. Not the panel, okay?
Okay,
What's really bad with solar is the inverter. You got to take DC current and turn it into AC. And
okay.
so that will put 20
Oh, of course.
kilohertz or
Yeah.
20,000 cycles on the wires everywhere. There's been all kinds of white papers written on it, and
Mhm.
and solar does not comply with the IEEE 519. It's
Right.
where you can't put so much back online.
Right.
And so this big solar push, and not only does it put it on the ground, or I mean on the wires, it puts it on
Mhm.
the ground. So even if your neighbor's got solar, your numbers will go really high.
Oh my
Uh,
goodness.
and it's very bad, and it's 20 kilohertz. Okay,
Uh,
so and the World Health Organization, the Russian government, the Japanese government, they all say that the most biologically active frequencies are between 4 kilohertz and 100 kilohertz. And here we got 20,
oh
and the
man.
smart meter's 50, and that Dell computer's 16.5 and 12.5. So you see, that's the kind of doom and gloom part of it, but
Right.
you can
Right.
get rid of it.
Uh-huh. Interesting. Okay, so then if somebody has the Internet of Things, the idea that now you've got smart devices, your fridge is smart and your all the various things. Um, first of all, how does somebody know? Is basically everything smart these days if we buy something new?
No, that, okay, I don't see so many smart refrigerators and things like that coming out on the market anymore because so many
Oh,
people are getting sick and complaining and all that.
oh,
When I'm
good.
talking about smart, the, the smart meter can transmit
Okay.
long distances, okay?
Uh-huh.
But your refrigerator and your stove and the dryer and things like that, your appliances,
Uh-huh.
if you put that, the smart, so that could talk to these satellites, right? It
Right.
would be really a lot of power and people would really be sick. So
Uh-huh.
what they did is said, well, let's use low power and we'll
Uh-huh.
send it over to the smart meter and then the smart meter will boost it up and send it out.
Got it.
Okay. But even then it's low level radiation. And I know a lot of people are complaining and, I don't see so much of that anymore as far as the transmitting part. And if you do, and it is, I would go in the back, take there's on the PC board, it'll say Wi-Fi and unplug it.
On the
Look,
PC board.
printed circuit board, yeah, in the back, yeah.
Oh, okay. So you can actually go into those devices and actually unplug the Wi-Fi component.
Yeah,
Oh, wow.
yeah,
Okay.
just
Well,
make sure it's unplugged. You don't want it. There's a little printed circuit board on some, and I think there's some YouTube videos out there, some too,
it'll
that'll
show
say
you.
Wi-Fi on the circuit board, unplug it.
Right.
Uh, you don't, look, when I buy a refrigerator, I want it to keep my food cold.
Exactly. Like, why do we need all the rest of this?
Why does the electric utility or the government or anybody else need to
Sure.
know
Yeah.
what's in my refrigerator
Right.
and those things? I just want to keep it cold. I
Yeah.
want to put my clothes in a washer and push a button and come back in there clean.
Right. Yeah. Yeah. So, in some areas, people will say, like the oscilloscopes apparently will read that the ground outside in neighborhoods can be dirty. Is that true? Am I understanding that correctly?
Absolutely, yes, yeah.
Okay. Why? What's going on? How does that?
Well, the United States, well, North America, okay,
Okay. Okay.
um, we use what we call a grounded Y system. Europe uses an open delta system. Okay, so what it is, you got the substations,
Mm-hmm.
and we generate power at the power plant and we send it to a substation. Okay, from the substation, it comes down the line to these transformers here.
Mm-hmm.
Okay, so every electron, the power that goes out on the wires
Mm-hmm.
in like Europe has to return to the substation, okay, on a
Neutral.
wire.
Yeah.
Okay,
Okay.
it's Kirchhoff's law. For every electron that leaves a node, one has to return.
Yep.
Okay, so in Europe, what went out on a wire has to return on a wire. If
Okay.
something happens to the wire, the system shuts down. In North America,
We didn't do
we use
that.
what we call a grounded Y system.
Okay.
All the power that goes out on the wires, right? When it comes back to the substation, it has two paths. One's on what we call a primary neutral wire,
Uh-huh.
and the other one's the ground. And so they drive a ground rod on all the poles, and it helps, take that high frequency current back to the substation. Now, the bad part is that in your house, that ground wire is also bonded to your water pipes.
Okay.
It's bonded to the ground, that third wire on your outlet, that for, so if you plug in your frying pan, it's got that third prong on, you've just now connected that to the ground. Uh,
Uh-huh.
so the ground in 1998, okay, Minnesota Science Advisors and EPRI, Electric Power Research Institute, the electric utility's own research arm,
Mhm.
found that 70% of all the current that goes out on the wires returns to the substation via the earth.
Wow. So
Not
it
down
doesn't,
in the earth, but on the earth. Okay.
so it doesn't, if it's returning on the earth, does it all actually get back there or does it just
Yeah.
dissipate? It does. Okay.
Well, yeah, for every electron that leaves, one has to return. Okay.
Yeah, but it has to return to the place it came from?
Yep.
Still
That's
does. Okay.
Kirchhoff's law. We can't change the
Okay.
laws of
Okay.
physics.
All right. So, all right. So then that's the reason why. And is that the reason why if people buy grounding mats, some people feel awesome and some people feel terrible because their grounding system can be contaminated? Is that the case?
Well, in North America, a lot of that grounding mat crap, and I
Yeah.
call it that, and I don't mind it saying it. Okay. I got the measurements that prove it. Okay.
Sure. Yeah, I believe you.
But yeah, I can't, and a meter doesn't care. It's binary,
Right.
ones and
Right.
zeros. Don't have an
Uh-huh.
opinion. But in Europe, a lot of that research was done in Europe. Okay. Now,
Yeah.
the human body, if you're sitting here right now and you're sitting in front of that computer,
Uh-huh.
you're building a charge. I mean, there's electrons in your body. You're going to build up a charge. Is
Mhm.
it good to discharge? The
Mhm.
answer is yes. Now, people in Europe, they laid on these grounding mats. Well, it had nothing to do with the ground. It had to do with the conductive surface. Okay. And
Okay.
so you get the same amount of electrons on one side as the other. Okay. So, but what happens is they wrote all these papers. They felt better and things like that by laying on these grounding mats. Basically, all they were doing is discharging. It doesn't matter. But in North America, it doesn't work that way because you're actually, would
Mhm.
you climb up the pole out, on your electric, in front of your house and hook a wire onto that bottom wire and
Mhm.
then bring it in and hook it to a mat and then lay on it? Probably not. Well, that's exactly what you're doing by plugging in just to that third prong on your outlet or drive a ground rod outside and hook to it.
Mhm.
So actually, you're connecting yourself to the electric utilities primary neutral wire. So in North America, and that's why people do get sicker from it. Now, why pay $150 for a ground mat? You can take a piece of aluminum foil out of your kitchen cupboard and
Mhm.
stand on it for about a minute. Okay, depends on your body shape, and I don't know why. We did research in Russia with these professors of medicine.
Mhm.
And if you're a heavier person, okay, you discharge faster than somebody who's smaller and more petite.
Okay.
Okay. But everybody discharged within a minute or so. Okay. So
Yeah.
and we have measurement instruments to measure it with. So if you
Right.
just stand on a piece of aluminum foil,
Mhm.
see what happens in your body. This charge is like, remember I told you when you're in dirty power, the electrons move to one side. Okay. Well, then they move back and
Uh-huh.
you get this oscillation. Okay. So that's like a charge and we
Uh-huh.
can measure it.
Right.
Okay. So now what happens is the electrons move to the atoms on your other side of your body. What happens is too many of them move. Well, now we created holes in the atoms on the other side. So
Okay.
then they move back. Well, too many move, and it keeps on going.
Uh-huh.
Well, if you stand on a piece of aluminum foil, what you did is they don't take going back through like this. They
Okay.
short out, like a capacitor leads. You touch them together, boom. So then what happens? You got the same amount of electrons on one side as the other. So
Uh-huh.
there's nothing to attract them over. You know. So you're
Okay.
discharged. So before you go to bed at night, stand on a piece of aluminum foil for a minute. Hop in bed. You shouldn't be any place charging up.
So how is that different? I mean, with the idea of like grounding paint and the things like that, I've or not grounding paint, but shielding paint, I guess I should say. But they say you're supposed to ground that too.
It
If you have
worked again, that research, that's a good question. Okay.
okay,
And the answer is in Europe, they grounded it. Okay.
okay,
But the ground it's sort of, people think of the ground like a sponge.
uh-huh,
Okay.
yeah,
So if we drop water on a sponge, we don't see it. So if we can put this signal, these electrons in the ground,
right,
right, we never see them again. Well, in Europe, that's one thing. But when we have a grounded wise system,
uh-huh,
it's not like a sponge. We drop water on it. It's like dropping water on a brick. We put it on there. We got water to deal with.
uh-huh,
Okay. But in North America, if you hook ground that paint, so you painted this wall with this, or conductive paint, and
sure.
then you ground it. What you did is you made yourself a big satellite dish, and
That's
now you
fantastic.
connect it to high frequencies because the ground is full of these high frequencies.
Which
So
is
now you're
exactly
hooking.
that's
So
the
you're
same
not
issue, right?
you're not bleeding anything off. You're sucking it in, and now you're going to stay in that house.
Okay. Okay, so it's the exact same issue with the grounding mat. Same thing. It's just
Yes.
you've basically you're an antenna. Okay. So if you have something that's just a shield, like a Faraday cage, for example, that doesn't
Mhm.
have to be grounded. That's just blocking, right?
Right. It
Actually,
reflects.
okay,
Yes. Mhm.
got it. Okay, got it.
Yeah. No problem. I mean,
Sure.
if you're stuck somewhere, a hotel or apartment buildings, and like New York is terrible. You got Wi-Fi above you and below you and
Sure.
whatever, then you maybe have to get into like a Faraday's cage in your bed. That's fine. It'll
Yeah,
block it.
yeah.
It's,
Right.
you know,
Yeah, and I've heard debates on that as well, like those the netting that goes over the bed, for
mhm.
example, and they're incredibly expensive. But some say that you feel worse if you don't ground it. Now it sounds like you feel worse if you do ground it. That makes more
Well,
sense to
go
me.
by your meter, okay?
Got
You
it.
put a
Okay.
meter in
Right.
there, and you go by the meter. A lot of people put them over their bed, okay? But they
Mhm.
don't do anything with the floor underneath. And so the problem is that the guy
Mhm.
downstairs has Wi-Fi or something or a
And
phone or
then it's
whatever.
going up through the
And it comes
ceiling.
up, and once it's in there,
Mhm.
it can't
Now
get
it's
out. And
uh,
now you not only get it from the side from the bottom side, now it hits the roof and it comes down, hits the walls.
So
It's
you become a little cage.
like a little rotisserie. Yeah, absolutely.
Got
Yeah.
it.
So it can
Okay.
make it worse. So you go by your meter.
Uh-huh. Yeah,
Like I said, meters don't have opinions.
sure. And that sounds like it would be more of an issue if you're on the second or higher floor, but if you're on the ground, that shouldn't be an issue, right?
No,
Yeah,
no,
theoretically. Okay.
theoretically.
Just
Yeah.
making sure.
No, no, no.
Okay,
That's
and
right.
then so as far as the not the meters, the filters are concerned.
Mhm.
So my understanding is sometimes when you plug those in, you can actually create a little magnetic field in that general vicinity. Am I understanding that right?
Okay, if you plug it in and you put the Gauss meter right up and you actually got to touch the filter,
Uh-huh.
you're going to read 4 milligauss. Okay.
Okay. Okay.
If you pull it away 4 inches, it
Uh,
will drop to zero.
Okay. So
So nobody's 4 inches away from the wall. I mean,
sure.
if you are, move something, so you're
Yeah,
not.
yeah. No,
But
that makes
yeah, so yeah, so then anything that draws current is
mhm.
going to have a magnetic field.
Right.
So if you got a lamp plugged in, you're going to get just as much or more. If you
Mm,
got anything like that plugged in, you're going to
mm,
get, anytime you turn on a light bulb, you're going to have a
right.
magnetic field.
And what if somebody has faulty wiring in their house? Will that make a difference as far as how the filters work?
Okay, I've heard that a lot. Okay, and usually it's the building biology that people that find this wiring errors, they call it.
Uh-huh.
Well, I'm a member of the IEEE. I've been in business 50 years. I've never seen it. None of my colleagues have ever seen it, anything
Really?
like that. Now, we had to create, we did it in the lab, okay? And what they're defining as a wiring error is if you got a light bulb over here and the hot wire comes and then it's supposed to be running back, like Romex wire has a black wire and a white wire.
Yeah.
Well, okay, it comes out on the black wire, the current goes through the light bulb and then it goes back on the white wire. Well,
Uh,
they're saying, well, we disconnect this white wire and we hooked it to another white wire that's over across the room somewhere.
right.
Well, first of all, it's against the code. It's against no electrician would ever do that or something like that. Oh,
Mhm.
well, they find it all the time. And then there's a guy that will come and straighten it out for you for $5,000. Well, okay,
Yeah,
but really seriously, I've never seen it.
sure.
I haven't, nor any of my colleagues or anything like that. And we've had building inspectors and electrical inspectors for years, and they
Uh-huh.
would never, and there's a rough-in inspection, and nobody would, but okay, but if you went ahead and somebody really did do that,
Yeah.
it wouldn't be the filter. When you plug the filter in, you're saying, well, we got this great big magnetic field.
Uh-huh.
It wouldn't have mattered what you plugged in. A 60-watt light bulb would do the same thing with if you had your
Uh,
house wired wrong.
okay.
So it has nothing to do, in other words, if you're okay in the house now and it isn't, there isn't any problems and
Uh-huh.
that when you're putting the filters in, isn't going to make any difference than if you had a light bulb plugged in.
Got it. Okay. So you'd still have a massive electric field just by the fact that your hot wire and your neutral were separated from each other, regardless.
Yeah, when you separate them, yeah,
Okay.
then you get a magnetic field because
Got it.
the wires are normally laying next together. Like you got Romex or BX or however your whole anything is wired. You got to
Right.
have a wire that takes the hot wire out, and you got to have a neutral that takes the current back.
Uh-huh.
Well, they're always right next to each other, so
Uh-huh.
they're always out of phase with each other.
Hmm.
So when one's going positive, the other one's maximum negative. Okay, so they cancel each other. The closer they
Hmm.
are, the more, the better it is. Okay, so they're
Hmm.
insulated and they're real close together, and the
Yeah.
field's canceled. So you really won't get much of anything. Now, when you come to the box, of course, then you're separating them a little bit, you know,
Mhm.
because you get one side of the outlet and the other side of the outlet. So
Yeah.
then you can get a little bit more.
You'll get, yeah. Right. Which is
But
part of the reason why when you put your Gauss meter right up into your electrical
you got
box,
to go right
you
up
gotta
next to it.
high.
Yeah.
Yeah.
But then you
Got
drop
it.
back and it drops off.
Sure. Okay. Makes sense.
Mhm.
All right. So for people who are listening and feeling overwhelmed, what are some basics, like small changes that people can make if they don't necessarily have a strong reason to think this is a huge issue for them? How can they protect themselves without moving off grid at this point? What are some
Well,
suggestions?
actually, moving off grid can make things worse because usually you got solar, and that's bad.
Oh, interesting. Okay.
But there's nobody that's not affected by it.
Right.
People say, well, it doesn't bother me. Well, yeah, but there's nobody,
Probably
and I think they said once 5% of the population is, and I've heard 8%. I think everybody's affected by it. It's just that you're not making that
different
connection.
levels.
Okay.
Yeah.
Yeah,
Hmm.
because nobody's Superman. Okay. So Try to, and I'm not saying you can't use your stuff, but there's three things I worry about. Okay. One is what's on the building's wires. Okay.
Mhm,
That you can put filters in and clean it up.
mhm,
Number two, I worry about what's coming through space.
mhm,
That's your Wi-Fi, the transmitted signals from the smart meter, things like that. And
mhm,
that usually requires shielding if you can,
mhm,
but that gets to be kind of expensive
mhm,
and you better know what you're doing with it. So, so then you usually got to at least get some advice from somebody, on how
mhm,
to do it or something like that. You
mhm.
don't have to hire people to come out because most of the stuff you can do yourself. But
Yeah.
if you get somebody, they'll give you some advice of how to use it or do it, but again, you're gonna have to, the biggest investment is gonna be a meter. Okay, you're gonna have to
Mhm,
buy a meter because you're gonna make your decisions that way.
mhm, mhm,
So what's coming, through space, what's
mhm,
coming on the wires, and then what's on the ground.
mhm,
And really, you have no control over, or very little control over what's on the ground. That's an electric utility issue. But now if you have copper piping, for example, and you're getting huge magnetic fields off the pipes, you can cut the pipe, say 2, 3 feet of it when it comes into the house, put a piece of
mhm,
plastic in there and
mhm,
spool it. I had to do that to my house,
mhm. Yeah,
and it'll reduce the amount of exposure you have as far
right.
as contact current.
Got it.
And remember, um, there's something called contact current. And the National Institute of Health and Environmental Sciences did research in numerous well-programmed studies. They found that 18 microamps will cause cancer in numerous well-programmed studies.
Wow.
So that would mean if you went between the sink and the floor with a little voltmeter, you'd
Mhm,
only have to measure 9 millivolts, and then you would be exposed to 18 microamps.
mhm.
So,
Wow.
so I worry about what's on the ground too. So you
Mhm.
want to reduce that as much as you can.
Sure. So, and you mentioned get some advice. Where do people find like a professional who might be able to help them with this?
Well, there's people out there. I mean,
Yeah.
my phone never stops ringing.
Yeah.
They can call here. We have
Sure.
qualified people,
Right.
and I don't know. We haven't charged anybody for devices or for advice yet.
Right. Yeah.
You know,
Mhm.
so I mean, we did it to make people get better, not to make
Right.
money.
Yeah.
But there's shielding material that you can buy that's looks like aluminum foil, and
Mhm,
it's like I think it's $5. It comes on a roll, like 4 feet
mhm,
high. And so then for $15, you can block it. You got to think about like a mirror, but you can put it on the backside of the smart meter,
mhm, mhm,
because that puts a huge burst of energy every 20 seconds back into,
mhm.
all directions.
Right.
Well, if you put that behind the smart meter,
Mhm,
okay, then it hits that and it reflects it back out. And
mhm.
now some people sell these, like, it looks like a cage that goes over the smart meter.
Yes. Yeah.
Yeah, well, they go out in the yard and they say, look, we got, 1,500 microwatts per meter squared. Now we put the cage on, it went down to 900.
Mhm,
It really did.
mhm,
But where did there was no less radiation, okay? But it
mhm.
gets reflected back into the house. They only covered the outside of the meter.
Oh,
See,
right.
we don't live out in the yard. You gotta, their meter's right, but look, I
Yeah.
want to go take the measurements in where we live. They're
Like on
gonna
the
go
other side
from,
of the wall. Yeah. Mhm.
yeah, and you're gonna find that it takes it right back. So put something on the back side of the meter and reflect it out away,
Sure.
you know.
Well, if your smart meter is on top of your electrical box, which is metal, doesn't that do it? Or do they still need something else on that it doesn't?
No, the metal, it'll go right through the metal. The
Uh,
radiation, yeah.
yeah, yeah, okay. So yeah, I was thinking, I guess it depends on the type of metal because aluminum foil is blocking.
Well, okay, when I'm talking about foil, well, here, I have this sample here, but you can see this foil, okay?
Huh?
But if you cut it and you looked at it from the end,
Uh-huh.
there's like a material in it. If you really look close, maybe you can kind of see the weaving.
Oh
There's
yeah. Huh?
actually there's actually a material, or a webbing in there, and so they got like a foil. They got a layer of resin, then they put a layer of this material, and then they put a layer of foil on it, so it gets to be like a heavy duty foil. But
Sure.
then what it does is it reflects it right out.
Mhm.
Okay, so it isn't like tin foil in your house because it might help a little bit, but mostly it's gonna go through it.
Okay, so but it is the aluminum that's actually reflective, correct? As
Yes.
yeah, okay, so that's the
But
material.
this stuff, and then see what happens, the radiation. it's like a screen, this material,
Yeah.
and so when it hits that, it kind of bounces around in there, see,
Uh-huh.
and you got another foil on the other side of it that kind of then puts it out. That's like we used to have screen rooms in the military when we tuned transmitters and things,
Yeah.
It was like copper screen, and then the size of how far the screen was apart. But it hits it and it bounces around and it's going.
Got it. Okay. Awesome. So what have I not asked you that you think is important to leave with our audience?
I don't know, you're pretty good.
Okay. Awesome. Well, where can people go to learn more about you?
Well, you can go to StetzerElectric.com.
Stetzer.
Uh, and you can call me, and I'll call you back. I mean, I'm on the phone quite a bit, but there's nobody that I haven't called back. So
Mhm.
even if you just, and we have real people that answer the phone, so we don't have machines. Not
Mhm.
that we're old fashioned, or well, we're kind of old fashioned that way, because I don't like talking to machines, and
Sure.
I guess
Yeah. Who
most
does?
people don't. So
Right.
somebody's going to answer the phone, and they're either going to patch you through to me or Adam or Marie or Larry or somebody, whoever you want. And sometimes I'm on the phone with somebody, but I always return my calls. It might not be right that minute, but you'll get a call back the very day you call.
Awesome. I will link to that in the show notes. And thank you so much. This has been extremely informative. I really appreciate your time.
It's kind of like I said, everybody's affected by it.
Mhm.
And I was in Russia, and there was an example the guy gave me, because I'm not a medical doctor, so that's the farthest thing from me. Okay, so they had to make things really dumbed down for me, and so they said, okay, if you got three people in the room, and somebody brings a cat in, and we're all allergic to cats,
Mhm.
okay, somebody might start wheezing, somebody's going to start, like coughing or sneezing, and somebody eyes watering, and somebody's going to break out in a rash, okay, like that. So now we can go and we can take an antihistamine,
Mhm.
and that'll help us.
Mhm.
But the best thing to do is get rid of the darn
Cat.
cat. Okay.
Right. Sure.
So this our bodies aren't used to these fields, okay? They're
Mhm.
man-made. And so your body, when you're around it, produces histamine.
Mhm.
So it's like the guys with the cats. Everybody's body was producing histamine, but we didn't all have the same reaction, you
Right.
see.
Sure.
So it's the same with this. And so the best thing to do, because your body really does produce histamine, you're actually like allergic reaction to these fields. So
Mhm.
different people react differently.
Mhm.
Okay. So then if you go ahead and you just get rid of it, clean it up, why go to the doctor?
Yeah.
And really, chronic fatigue, fibromyalgia, ADD, ADHD, kids,
Mhm.
when we cleaned up their electrical environment, okay, and I have to say that, I used to say, well, when we put the filters in,
Mhm.
well, okay, but I can't say that anymore.
Mhm.
Well, you got to put them in. That's the first thing, okay?
Mhm.
But uh, you're still exposed now to things that we weren't exposed to before.
Right.
I mean, with
Yeah.
the smart meters, we didn't have them. We didn't have Wi-Fi and things like that. So
Mhm.
now you can put the filters in, and you feel, okay, yeah, I feel really good, but I don't sleep too good at night.
Mhm.
Wi-Fi is usually
You're still
okay. So then if you have to have it, put it on a timer. But
right.
there's a lot of doom and gloom, but I always say, well, okay, there's an engineering solution to an engineering problem.
Mhm.
And can we use it, and can we use it safely? And the answer is yes. There's methods that we can do to use it.
Mhm. Mhm. Perfect. Sounds great. So I will link in the show notes to your website so people can get a hold of you and really appreciate your time. Thank you.
Sure, thanks.